Every call to Azure OpenAI costs you money and latency. A chat completion can take 1 to 5 seconds and burn thousands of tokens. And in most production apps, a surprising share of prompts are near duplicates. Caching responses with Azure Cache for Redis can cut both your bill and your tail latency dramatically. But caching language model output is not the same as caching a database row. In this video, we'll walk the decision. When to cache, exact match versus semantic caching, how to wire it in Python, and the traps that make caching actively harmful. Before you cache anything, weigh 4 things. First, repetition. If prompts are highly unique, your hit rate is near 0 and you've added complexity for nothing. Second, staleness tolerance. Can a user accept an answer generated minutes or hours ago? For deterministic factual lookups, yes. For personalized or time-sensitive replies, no. Third, correctness risk. Returning a cached answer to a subtly different question is a real failure mode. Fourth, cost of a miss versus a hit. If these line up, caching pays off fast. If they don't, you're shipping bugs to save pennies. 2 strategies. Exact match caching hashes the normalized prompt and stores the response under that key. It's trivial, fast, and zero risk of returning the wrong answer. But it only hits when prompts are byte-for-byte identical. Semantic caching instead embeds the prompt into a vector, then uses Redis vector search to find a previously stored prompt within a cosine similarity threshold. It catches paraphrases and boosts hit rate, but it costs an embedding call per request and can return a near-miss answer if your threshold is too loose. Start with exact match. Reach for semantic only when your hit rate is too low. Here's the flow for semantic caching. The client sends a prompt. Your app embeds it with an Azure OpenAI embedding model, then runs a vector similarity query against Azure Cache for Redis using the enterprise tier, which supports the RediSearch vector index. On a hit above your threshold, you return the stored completion immediately. On a miss, you call the chat model, then write the new prompt vector and its response back into Redis with a time to live. Use the enterprise tier here because vector search modules aren't available on the basic and standard tiers. In Python, the exact match version is just a few lines. Normalize the prompt, hash it to a key, and check Redis before calling the model. On a miss, call Azure OpenAI, then set the response with an expiry so stale answers age out automatically. This pattern alone removes redundant calls for identical prompts and is safe by construction. For semantic caching, you'd swap the hash lookup for an embedding plus a vector query, but the read-through, write-on-miss structure stays exactly the same. Caching introduces correctness hazards you must design around. If your prompt includes per-user context, personalization, or the current date, a global cache key will leak one user's answer to another or serve yesterday's data. Fix this by including all relevant context in the key, or scoping keys per tenant. For semantic caching, a threshold that's too loose returns confidently wrong answers. Too tight and you get no hits. And remember non-determinism. If you cache at temperature above 0, you freeze one sampled answer forever. Cache deterministic calls, or accept that variety disappears. A few rules of thumb. Set time to live based on how fast your underlying knowledge changes. Minutes for volatile data, hours or days for stable answers. For semantic caching, start your cosine similarity threshold around 0.95 and tighten if you see bad hits. Pick the Redis tier deliberately. Enterprise for vector search, standard if exact match is enough and you just need replication. Always track your hit rate and tokens saved as metrics, because that's the only way to know caching is actually earning its keep. Pricing and tier features change, so check the current Azure docs before you commit. So, cache Azure OpenAI responses when prompts repeat. Staleness is acceptable, and wrong answer risk is manageable. Start with exact match caching in Redis because it's simple and safe, and only graduate to semantic caching with vector search when your hit rate is too low to justify the call volume. Always put full context in your key, set sensible time to live values, and measure your hit rate. Your one concrete action this week. Wrap your highest volume Azure OpenAI endpoint in a read-through exact match cache and watch the token savings. Then decide if semantic caching is worth the extra complexity. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.